Hi everyone, you're welcome again. So today we are going to solve problem on area and volume expansivity. So let's get started. The question says a rectangular metal block of volume 10 raised to power minus 6 meter cube at 273 Kelvin is heated to 573 Kelvin. If its coefficient of linear expansivity is 1.2 exponential minus 5 per Kelvin, calculate the percentage change of its volume. So before we calculate the percentage change, we have to calculate what? Change in volume. Now, solution. The first thing is to bring out your datas. A rectangular block of volume this at this temperature. If you see, this temperature is 273 and the other temperature is what? 573. It means that initial temperature is what? 273. So the volume at initial temperature is what? 10 raised to power minus 6 meter cube, which is our initial volume or original volume. So I have V naught is equal to 10 raised to power minus 6 meter cube. Then initial temperature, theta 1 is 273 Kelvin, and the final temperature theta 2 is 573 Kelvin, and we are given what? The coefficient of linear expansivity, which is 1.2 times 10 raised to power minus 5 per Kelvin. So what are we looking for? We are looking for change in volume. Change in volume, which is what? Delta V. So the next thing is to recall our formula. Recall that for volume expansivity, you have the coefficient of volume expansivity, which is what? Gamma, is equal to change in volume all over original volume into change in what? Temperature, which is theta 2 minus theta 1. But in our question, there is no what? There is no gamma. We are given alpha. So, but remember, gamma is equal to 3 alpha. So in our formula, I will now put what? 3 alpha is equal to change in volume all over original volume into theta 2 minus theta 1. Is that clear? Good. Then I now substitute my what? I substitute my values. What is my alpha? 3 times 1.2 times 10 raised to power minus 5 is equal to change in volume all over. Original volume is 10 raised to power minus 6 into final temperature theta 2 is 573 minus initial temperature theta 1 273. Yes. Then by the time I multiply this, I have 3.6 times 10 raised to power minus 5 is equal to change in volume all over 573 minus 270, that is 300. So 300 by what? 10 raised to power minus 6. That will give us 3 times 10 raised to power minus 4. So the next thing is to what? Cross multiply. Change in volume is equal to 3.6 times 10 raised to power minus 5 times 3 times 10 raised to power minus 4. So that will give us 1.08 times 10 raised to power minus 8 meter cube. So this is our change in volume. Change in volume is equal to 1.08 times 10 raised to power minus 8 meter cube. But the question is asking to calculate percentage change in volume. Percentage change in volume is equal to change in volume all over original volume times what? 100. Are we clear? So that will be change in volume. We have got it to be 0.8 times 10 raised to power minus 8 all over original volume 10 raised to power minus 6, then multiply by 100. By the time I do that, I'll end up having 1.08%, which I can approximate to be what? 1.1%. So percentage change in volume is 1.1%. So here I have shown you the ways in which you can use the relationship between the volume expansivity and the linear expansivity. A situation where you are given, the question is totally volume, but instead of the examiners to give you the coefficient of volume expansivity, they give you linear expansivity. You don't need to panic. All you need to do is to use the relationship between the linear expansivity and coefficient of volume expansivity. Thank you.